6 predicted questions with answer for Combined Science AQA GCSE Chemistry Exam, Paper 3, 2024. Question 1. Write the chemical formula for compound X, which could be something like sodium sulfate or ammonium nitrate. Remember that you need to know the charges of the different ions. For sodium sulfate, sodium has a charge of 1 plus and sulfate has a charge of 2 minus. So sodium sulfate would be Na2SO4. Ammonium nitrate, ammonium ion is plus 1 and nitrate is minus 1, so the ammonium nitrate would be NH4NO3. Question 2. What are the group 0 elements known as? The answer is noble gases. Question 3. The graph below shows the boiling points of group 0 element. Explain the trend in the boiling point. So the answer you can see as we go down the group, the size of the atom will increase and the boiling point increases as we go down the group. The increase in the size of the atom means there is an increase in the intermolecular forces of attraction between the particles, so more energy will be needed to break the forces, and so there is an increase in the boiling point. Question 4. Calcium react with silver nitrate to give silver. So this is the equation. The equation is incomplete. So the first question is to complete the balance the equation. Question B is to write the half ionic equation that shows that calcium is oxidized in this reaction. So the answer for A, we need to balance the equation. Calcium will give you the ion 2 plus because it's group 2 element, and then silver nitrate as we can see here. So calcium plus 2 silver nitrate will give us calcium nitrate because nitrate has a charge of minus 1 and plus 2 silver. So this is the balanced equation. And then we need to write the half ionic equation. So calcium will be oxidized to give you the ion calcium 2 plus 2 electrons. Question 5. Explain why alloys are harder than pure metals. You need to compare between the alloys and the pure metals. So pure metals, the atoms are arranged in layers with regular arrangement. The layers can slide past each other when hammered. They are not very hard. Alloys, on the other hand, contain a different size element added to the metal. This different size element will distort the regular arrangement of the metal, and the alloy becomes harder. Question 6. Calculate the overall energy change of the reaction. This is an example from a past exam paper where you have hydrogen peroxide decomposes to give water and oxygen. And then there is a table that gives you the bond energy for all of the different bonds. To answer this question, you need to first calculate the energy needed to break the bonds for the reactants. We have hydrogen peroxide here. For each hydrogen peroxide, we're going to have two OH bonds, and then we have 2 moles or 2 molecules of hydrogen peroxide. So in total, there are 4 OH bonds. So this is why we multiply 4 times the bond energy, the energy needed to break the OH bond. So it's 4 times 463. And then also we have an oxygen-oxygen single bond, and we have 2 of these because we have 2 moles. So 2 times the 138, which is the bond, the energy needed to break the oxygen-oxygen single bond. In total, there is 2,128 kilojoule. And then we need to calculate the energy needed or released when the bonds are formed for the product. We have 2 moles of water. In each water molecule or in each water molecule, there are 2 OH bonds. So in total, there are 4 OH bonds, so 4 times 463. We also have 1 oxygen double bond, so there is also we're going to add the energy needed or the energy released when 1 oxygen-oxygen double bond is formed, which is 496. So in total, it's 2,348 kilojoule. Then the overall energy change will be the total of the energy needed to break the bonds minus the total energy released when the bonds are formed, and when we put the two values, we're going to end up with an overall energy change voltage of minus 220 kilojoule, which means this reaction is an exothermic reaction.